Here we have some exercises. The first one says minus x plus 1 divided by 2x minus 1. Okay, so the first step is to evaluate vertical asymptotes. Okay, how do we calculate vertical asymptotes? It's just whatever makes the denominator equals to 0. Our denominator is 2x minus 1 and then equals to 0, and we look for x. That will be 2x equals to 1, x is equal to 1 half. So at x equals to 1 half, we have an vertical asymptote. Okay, so that's one tip. So let's draw a vertical asymptote at x equal to 1 half. That will be here. Okay, so once we have the vertical asymptote, the next step, step number 2, is to evaluate horizontal asymptote. How do we do this? We compare the power in the numerator and the power in the denominator. In this case, both powers are the same. So what we do is we divide the coefficient in the numerator, which is minus 1, over the coefficient in the denominator, 2. Okay, and this is our horizontal asymptote. Okay, so that will go through the point y equals, this is y equals minus 1 half, and this will look like this. Okay, so now that we have our horizontal and vertical asymptotes, the step number 3 is to calculate if any slant asymptote, but we don't have slant asymptote. Why? Because that's only when the power of the numerator is greater than the power of the denominator. In our case, both of them are the same. We already got our horizontal asymptote. So the next step will be to calculate for the X intercept. Okay? So how do we do this? For the X intercept, we say that f of x is equal to 0. So we take our fraction right here and we set it equal to 0. So we have minus x plus 1 divided by 2x minus 1 equals to 0. We take the denominator and go to the other side, multiply by 0, so it's just 0. Then minus x plus 1 is equal to 0. Then x is equal to 1. Okay, so this x equal to 1 is X intercept. Okay, let's mark that point here. Now that we have this point, we need to calculate the Y intercept. How do we do this? For the Y intercept, we need to set x equal to 0 in our function. So for x equal to 0, we have minus 0 plus 1 divided by 2 times 0 minus 1. This is 0, this is 0, so we have equals to minus 1. So the y-intercept is at minus 1. That will be right here. So the next step is to do the sign analysis. How do we do this? Sign analysis. Well, we just look closely to our graph, right? We know that it's happening on this side and on this side because we have our two intersections right here. We just evaluate a number on this side and a number on this side. So let's say, let's get x equals to 2 and see what y is. Okay, so on this side, if we get x equals to 2, then y is equal to minus 2 plus 1 divided by 2 times 2 minus 1, and this is equal to minus 0.3. Okay, so when x is equal to 2, then y is equal to minus 0.3. That is very, very close to the asymptote. It will be somewhere over here. Okay, now let's evaluate x equals to minus 2. So x equals to minus 2, then y is equal to minus 2 plus 1 divided by 2 times minus 2 minus 1. This is equal to minus 0.6. Okay, so when x is minus 2, then y is minus 0.6. So somewhere over here, very close to the asymptote, but remember, never touching the asymptote. Okay, so with these points, we can already graph our function. It will look something like this. And as you can see, this graph, as it grows to the left, it gets closer and closer to the asymptote, but never touches the asymptote. Same as when it goes down. It goes down, down infinitely, but it will never touch the asymptote. Same on this side. As it goes up, it gets closer to the asymptote, but never touches, and to the right as well. And that's how we graph this rational function. Okay, so let's do now this exercise. The first step is to analyze if there is a vertical asymptote. How do we do this? We set up the denominator equals to 0 is x minus 1 equals to 0, x is equal to 1. So our vertical asymptote is in x equals to 1. That will be like this. Now let's evaluate if we have horizontal asymptotes. For horizontal asymptotes, we compare the powers of the numerator and the denominator. In this case, these two powers are equal. What means is that we divide the coefficient of the numerator, coefficient is whatever is multiplying the highest power, and the coefficient of the denominator. So 1 over 1 is equal to 1. So at y equals to 1 is our horizontal asymptote. Okay, now that we have our two asymptotes, the next step is to get the X intercept. How do we do this? Well, we set up the function equals to 0. Okay, so we have x plus 6, x minus 1 equals to 0. Then we have x plus 6 equals to 0, x equals to minus 6. That's our x intersect at x equals to minus 6. So right here. Now let's calculate the y intersect. How do we do this? We set x equals to 0 and calculate for y. Y is equal to, our function says x plus 6, that will be 0 plus 6 divided by x minus 1, that will be 0 minus 1. So that will be at minus 6. So our y-intercept is at minus 6 right here. Okay? So with these 2 points, we already know that our function is happening in this area, right? Because we have the x-intercept and the y-intercept. What about this area? That's where my logic would push me towards. So I'm going to evaluate numbers in this area to see if I get my function. Okay, so let's evaluate x equal to 2. When we evaluate x equals to 2, we get y equals to 2 plus 6 divided by 2 minus 1. That will be 8 divided by 1. So our function when x is equals to 2, y is equal to 8. Okay, that will be somewhere over here. Okay, so we know that our function happens here and here. Okay, and when we have polynomials with degree of 1, so x to the 1 power, it would have a shape like the one we did previously, like this one. Okay, so but let's keep evaluating more numbers. Let's evaluate 4 in our functions. If we have x equals to 4, then y is equal to 4 plus 6 divided by 4 minus 1. This will be 10 divided by 3. And this will be 3.3. Okay? So when my function is in x equals to 4, the y is in 3.3. So it will be somewhere over here. Now let's evaluate minus 1. If we evaluate x equals to minus 1, we get y equals minus 1 plus 6 divided by minus 1 minus 1. Then we have 5 divided by minus 2. That will be minus 2.5. Okay, so when we are in minus 1, we have minus 2.5. That will be here. Okay, let's say x equal to 6. Then we have y equals to 6 plus 6 is 12 divided by 6 minus 1 is 5. And this is equal to 2.4. Okay, so when x is 6, then I have 2.4 right here. And with all these points, we can already graph our function. It will look something like this. Okay, so this is how we graph our rational functions, just by following the steps and start evaluating points in both sides of the asymptotes.